Okay, question 14, we have a message. We also have circles. So, the circle C has equation x squared and y squared minus 6x add 10y add 9 is equal to 0. Part A wants us to find the coordinates of the centre and the radius. Okay, so the general equation of a circle, I've got loads of this stuff in my coordinate geometry playlist down below too. So a circle centered, A, B, radius R has equation x minus a squared add y minus b squared is equal to the radius squared. So we need to rewrite this equation in that form. So let's reorder it. Let's write it as x squared minus 6x add y squared add 10y add 9 is equal to 0. Now what we need to do is complete the square for the x terms and the y terms. So x squared minus 6x is going to be x minus 3 squared. If you're rusty on completing the square, check out my polynomials playlist. So we get x minus 3 squared minus 9, and then the y terms are going to be y add 5 squared minus 25. Then we got the add 9 is equal to 0. Now the 9's cancel each other out. So we got minus 9 and a plus 9. So if we add 25, we get x minus 3 squared add y add 5 squared is equal to 25. So for part 1, the centre is at positive 3 minus 5, and for part 2, the radius is 5. Cool. Okay, then for part B, we're told the line with equation y equals kx, where k is a constant, cuts C at 2 distinct points. We want to find the range of values of k. Okay, so this is simultaneous equations. So we got y equals kx, and we've also got x minus 3 squared add y add 5 squared is equal to 25. Now, for the line to cut a circle, then the equations are simultaneous. Now the reason for that is at intersection points, the x and y values of the curve and the line are the same. So what we're going to do is substitute y equals kx into the equation of the circle. So what we're going to get is x minus 3 squared add kx add 5 squared is equal to 25. Now, for two distinct points of intersection, this equation has two roots. Or two solutions. So let's expand the brackets. So x minus 3 squared is x squared minus 6x add 9. Kx add 5 squared is going to be k squared x squared. Add 10kx add 25, so something nice at least happens here. So add 25 is equal to 25. Okay, so we can take the 25 away from both sides, and if we group common terms together on the left, we get x squared add k squared x squared minus 6x add 10kx add 9 is equal to 0. So we can factorize, so we can say that 1 add k squared x squared add 10k minus 6x add 9 is equal to 0. Now, we got a quadratic then. Now we are thinking in terms of the discriminant. So, for two real roots, the discriminant b squared minus 4ac is greater than 0. So a is 1 add k squared, b is 10k minus 6, and c is 9. So we're going to get b squared, so 10k minus 6 squared Okay, now we got minus 4ac. So minus 4 times 9 is minus 36 So we got minus 36 times 1 add k squared. Now we know that that is greater than 0. Lovely. Right. If we expand 10k minus 6 squared, we are going to get 100k squared minus 60k twice, so minus 120k, add 36 minus 36 minus 36k squared. That's greater than 0. So we got 100k squared minus 36k squared. So we got 64k squared. Now we got minus 120k and then we got add 36 minus 36. So that cancels out, which is good. So that stuff is greater than 0. Now we got some common factors. At least 4 goes into them both. So we got 16k squared minus 120 divided by 4 is a number, 25, 30, of course it is. Still a common factor of 2, so 8k squared minus 15k is greater than 0. Factor out k, we get k times 8k minus 15 needs to be greater than 0. Now if we think about this as an equation, so k times 8k minus 15 is equal to 0, and that gives us k is equal to 0, or 8k minus 15 is equal to 0. Now if we solve that one for k, 8k is 15, so k is 15 over 8. Now if we think of this as a quadratic, what we've just found are the points where it crosses the x-intercept. So we got 0 and 15 over 8. Now we wanted k times 8k minus 15 to be greater than 0. So the parts of the graph that we want are this bit and this bit. So our two solutions are k is less than 0 or k is greater than 15 over 8. Cool.